Welcome to Probability Weekly Work Part 2, Homework Help. Dr. Hawk has 150 patients in an allergy clinic. 68 patients are allergic to dairy, 93 are allergic to pollen, 91 are allergic to fur, 31 are allergic to all three. 29 are allergic to only pollen, 12 are allergic to only dairy, and 40 are allergic to dairy and pollen. Create a Venn diagram and answer the following. So even though it's a lot to read, once you get your Venn diagram, it becomes a lot easier. I was going to use the shape maker. There we go. I don't see a shape. Well, okay, I guess I'll draw a shape. I can do that. I can draw a circle. Not a well-drawn circle. All right, so you need one circle for dairy. You need one circle for, of course, the circles overlap because some people fall in the allergic to dairy and fur group. And then we need one for pollen. And of course, all three circles have to overlap because some people are allergic to dairy, fur, and pollen. And then you want to create a box because you can have some people that have allergies, but it's just not to these three things. So there may be more people than are in these circles, and they would go outside the box if they don't fit any of these categories. We know how many total there has to be because there are 150 patients in the allergy clinic. All right, my helpful hint is to fill in. All right, I'll take yellow. Any color? Oh, purple, there we go. Purple, I'll take purple. Let's see what I get. No, I'm gonna get yellow. That's fine. Fill in this section first, the one that have all three, all right? And then you can go from there. If it says that it's like, so that has all three. So for instance, here, this part here, that's the dairy and pollen group. Make sure, don't forget these people here, they count in the dairy and pollen group, right? And they count in the dairy group unless it says dairy only, right? If it says dairy only or fur only or pollen only, then they're referring to this part here. Oh, I thought I grabbed blue. This part here, not the overlap. I'm going to just change that to blue just because that's the blue circle. I don't want to confuse anybody. Okay, did it change? No. Okay, we'll just color over it. Oh. We'll just cover over it. All right, there we go. Just so I don't confuse anybody. So if it says dairy only, then it's this group, not the overlap. But otherwise, you got to include the overlap first. So you'll subtract the very center group out from the pollen and dairy and the fur and dairy and the fur and pollen, all right? And then you would subtract the fur and pollen and you subtract both of these, this one and this one, for instance, from the fur, so you know how many are the fur only, because they count as fur. And over here, and this counts as fur too, right? So that's fur. Maybe I should use different colors. All of that's included in the fur. All of this and that center and this is included in the pollen, along with, of course, this. Voice is being really slow. Oh, looks like it may have paused. There we go. Am I going to get my little red asterisk? Nah. All right, so all of that's included in the pollen, the red asterisks. All of this is included in the fur. And then this, and this, and this, and of course the shaded blue is included in the dairy. So make sure you subtract out anything that's in the circle already, right, to find the fur only, dairy only, pollen only, unless you're given those values. Right, and so let's take a look at the 4 questions here. A is probability of allergic only to animal fur. So only animal fur means nothing else, right? Not dairy, not pollen, right? Only animal fur. Probability not allergic to dairy, pollen, or fur. Those are the people that are not in the 3 circles, right? So this is not in the 3 circles. The only animal fur is the probability of the fur only. Oh, so nice and straight, my writing. Probability allergic to dairy given the person is allergic to pollen. Notice that word given. This is conditional probability where you see given. So both of these is the same idea. So this is a probability of dairy given pollen. This is the probability of pollen given fur. And a good one to watch if you need to review is the conditional probability review. All right, that goes over these again, and it goes over it with a Venn diagram of all things. All right, so a hint if you want to review this, the video, the Nearpod is review conditional probability Nearpod. All right, so if you need to review any of that. And as a reminder, the conditional probability formula, so these 2 here, use the conditional probability. I have lots of asterisks on here. Use the conditional probability formula, and that's the probability of A given B is the probability of A. Oops, I did not mean to put an A there. Of A and B divided by the probability of the given probability of B. Okay? All right, so here is how to do these problems. This one took the longest to explain because that's the biggest problem in the set. Left-handed people, in a sample of 1,000 people, 120 are left-handed. 2 unrelated people are selected without replacement. All right, so the people are not going back. All right, what kind of probability is it if it's without replacement? What kind of events are these? All right, so just a little reminder. If there's more than one event, right, you're picking more than one person, you got to multiply the 2 probabilities. All right, so A is the probability of left and the probability of left, given you already picked someone who's left-handed. All right, so it's going to change the sample set. So you can just change the sample set rather than using the conditional probability formula. B, probability that neither person is left-handed. Well, if you're not left-handed, you must be right-handed. There are no other options on this, but in this one. We're not looking at probability of being ambidextrous. So probability of right and right given right, because these are the people that are not left. And then probability that at least one of the persons is left-handed. Number at least includes, so the first person, could be the first person is left-handed. Second person is left-handed. or both are left-handed. So what's the only thing it doesn't include? That none are left-handed. Whenever you have at least, it would be easier to use the complement right? So at least, the complement of at least one is none, right? Because the probability of none plus the probability of at least one covers all your options, because at least one includes the first person, the second person, both of them. The only thing it doesn't include is none of them. So together, those two probabilities equal 1. So you could also find the probability of at least, and the easiest way, rather than calculating all those probabilities out, would be to take 1 and subtract the probability of none, because at least includes everything but that. All right, so there's a big old hint on 11C. All right, now this is not too difficult, is it? All right, 12, you're planning a 3-day vacation to the mountains. Don't know why there's some dashes in there. Don't know why there's dashes there either, but a long-range forecast reports the probability of rain each day is 10%, assuming that the daily probabilities of rain are independent. Remember from the last video, that means raining on one day does not cause it to rain on the next. What is the probability that there is no rain on the first 2 days, but it rains on the third day? All right, this is 3 events, which means 3 probabilities. So it's the probability of no rain, no rain, and then rain. And those are complementary events, no rain and rain. Together, no rain and rain equals 1. Because either it's raining or it's not raining. Right? We're assuming that it's not cold enough to snow. So it's raining or not raining. Number 13 is a Venn diagram. Right? It's Julie and Pat. So if Julie is on the first branch, must be Pat. I'll give you that one. That's, oops, maybe not write it there, because you got to write the probability in there. I'll write it below. It must be Pat that's on the second branch. All right, so, oh no, sorry, that's all Julie. That's all Julie. This is all Pat. Never mind. This is all Julie. This is all Pat. I knew that. So you're filling in the missing. Remember that the probabilities on any one branch have to equal 1. That's right, you're not picking between Pat and Julie. It's just, this is Julie's info and this is Pat's info. All right, so I probably should have read the directions. All right, so the probability on any branch equals 1. I didn't put it that the right way I wanted to put it. On any set of branches, that's what I wanted to say. On any set of branches equals 1. So that means that has to equal 1, that has to equal 1, and that has to equal 1. You need to fill in the missing. So if these are, notice that it says the 2 events are independent. So the probability that Julie will arrive late is 0.2. So now, what would be the probability she will not arrive late? The probability that Pat will arrive late is 0.6. So what is the probability? Pat seems to be have a little bit of problem being late. The probability that Pat will arrive late is 0.6. What's the probability that she will not arrive late? If the events are independent, right? It says the 2 events are independent. It doesn't matter whether Julie is late or not late, Pat's going to have the same probabilities whether Julie is not late as she had when Julie is late. So you just fill in the missing spots there. So that's really easy. That's so easy. And then, I can't get B in there. Work out the probabilities that Julie and Pat will both arrive late. So this is going down a branch, or across a branch. I guess I shouldn't say down. Across a branch, when you, a probability of events across a branch, you multiply. So you will multiply the probabilities. So you want late and late, all right? And as always, the probability of two events happening is less than the probability of one of the events happening, because you have to have both things happening, right? So this one is not too difficult. It's a nice, easy tree diagram. Easier than the ones we did in the Nearpod tree diagrams. This is the last two problems in the homework. Kevin had 6 nickels and 4 dimes. If he took a coin out and then a second probability that both coins were nickels. So this is just probability of, I'm going to put N for nickel, probability of nickel and nickel, given that the first was a nickel, right? Because he did, this is without replacing. The second one, what's the probability that both coins were dimes? So you want the probability of dime and dime, given the first was a dime, right? So if you're not replacing, it'll change your sample set for the second probability. And then what's the probability that the first coin was a nickel and the second coin was a dime? So it's the probability of nickel and then the probability of dime, given the first one was a nickel. All right? And when you have more than one event, this is 2 coins, you multiply. Bella has 7 green beads, 10 yellow beads, and 3 white beads in a pouch. 2 beads are drawn without replacement from the pouch. What's the probability of the beads both yellow? So probability of yellow, so favorable, yellow beads over total beads, times, okay, this always means multiply, right? Because we have 2 events, she's picking 2 beads, you multiply probability. You always multiply when there's more than one event. So yellow bead, and then the times the probability that she picks a yellow, given the first was yellow. Right? And so now that you have seen this video, you can finish up the rest of the homework. And that shouldn't take you all that long, right? All right, thanks for watching. Bye for now.